Hey everyone, welcome to our presentation on exploring an Android malware.
Hi, I'm Sunny Lee.
And I'm Santiago Salas. We'll be walking you through our project. Our presentation can be split into four main sections. First, we'll talk a little about the goal of the project in the introduction. Then we'll talk about the static analysis of the malware itself. We'll then go over the lab environment that we set up, as well as show you a live demo of our dynamic analysis where we let the malware run in our lab. To wrap things up, we'll discuss some preventions and courses of actions that you can take to deal with malware. So why did we pick this project? So what was our motivation? For any of you that might recognize the slide template from Applied Crypto, after the failed attempts at creating our streaming app Glitch TV, we decided to pivot to malware analysis. On a more serious note, the reason we picked this project is because we wanted to learn about how Android malware might work. We also used this as an opportunity to try and learn how to properly analyze Android malware, which was definitely the most difficult and challenging part of the project. The malware we picked is an old malware called Krep that targeted a Russian banking app. The GitHub link also includes a link to a blog on zscaler that talks about the malware's behavior. The blog goes over some source code review, but they don't go into detail about how they set up their environment to analyze the malware or how they obtained the source code. We used the blog as a sort of reference to see if we could obtain the same findings. So what were the key takeaways from this project? Well, we learned how to decompile an APK to get source code, and we also learned how to set up an environment in order to observe the malware in action. We also got to see how some of the security principles that we learned in class could have an impact in a real-world setting right in front of us.
On the zscaler blog, we saw source code of the malware being cited, so we knew there had to be a way to obtain the source code from the APK. We looked online for several ways to obtain the source code from an APK. There was a few methods listed in a Stack Overflow post that we decided to try. We had the most success using JADX, which gave us Java code, which was a bit easier to understand compared to Smalley code. One of the main code snippets in the malware that we found was the use of WebView to load the malicious components of the malware, which wasn't mentioned in the zscaler blog. The use of add JavaScript interface is noted as dangerous in the Java docs for being able to give control of the host application to the script elements. In this code snippet, we see the functionality of sending SMS, which is weird for a banking app. This may not be expected, but more importantly, this is exposed via the web view as functional script elements available to the C2 server. This piece of code extends a broadcast receiver to act when SMS message is received. It uses the string builder class to append the content of the SMS message, which ultimately gets sent back to the C2 server. This code implements calling functionality to allow the C2 server to make calls on behalf of the infected victim. This screenshot is from the zscaler blog. This showcases information about a call being relayed back to the C2 server. We weren't able to see this in action due to not having a phone number tied to our Android VM, so we borrowed the screenshot. What we were able to find was where the parameters were defined. We also found another Java file called incomingcall.java, which extends the broadcast receiver class in order to react to calls being made to the victim. This blog also describes some overlay functionality that the malware uses to open an overlay over legitimate apps in order to trick the user into entering their credentials and then sends this back to the C2 server. We weren't able to replicate this feature in our live run. We believe this might be because we were using newer versions of the apps, or this relies on the setting being sent from the C2 server, which our app was never able to reach, though it definitely did try. This code snippet shows some effective form of persistence for the malware. The app on startup requests admin level permissions and requests to be added as a device admin app. If you try to remove it from the device admin app list, the device will lock and try to sleep, kicking you out of the menu so that you're not able to downgrade the app's permission.
So now for the dynamic analysis section. So as opposed to static analysis, where you are analyzing files on disk or the code itself, dynamic analysis focuses on observing the behavior of malware as it runs, seeing what it changes on the machine and what actions it takes. We're going to give a generalized procedure of our lab setup, but this is not intended to be a step-by-step guide, so please do not try to use only these slides to set up an environment yourself. We're only discussing some key steps, and it took a lot of troubleshooting, which we won't go into depth here. The original zscaler blog was also written 5 years ago. They didn't describe their lab setup, so our lab setup is not exactly the same. Since they already covered how the malware acted with older versions of WhatsApp and the banking app, we decided to observe how the malware would behave on a newer version of Android with newer versions of those apps. So first, let's go over some of the tools that we used. The main tool being VirtualBox, and we also set up a couple of VMs. One Ubuntu VM and another VM running Android 9. The Ubuntu VM will act as the observer. We'll be using this VM to try and see what the malware does. We set up a VM with Ubuntu 20.04. We then updated the distro and installed Remnux as an add-on. Remnux is a Linux malware reverse engineering distribution which is built on top of Linux and includes a lot of useful tools. We don't need all of them and will only focus on a few that we used in the presentation, but there's plenty that you can do with it. After we got the VM set up, we turned off the VM because we're going to need to update the network settings in a later step, which requires the VM to be powered off. Now for the Android VM setup, which will act as the victim in our lab and be the VM that hosts the malware. This by far took the most amount of time to configure. Maybe we got unlucky, but we had to go through several Android and VirtualBox versions, as well as tweak the VirtualBox settings for a total of maybe 20 hours before we were finally able to get a stable VM that was responsive and supported the functionality we needed. Assuming all the steps went smoothly, we condensed what we did into these general steps. We first obtained an Android ISO and created a VM. We also created a test Gmail user in order to be able to use the Google Play Store so we can download the legitimate versions of some of these apps. It would be very helpful if you knew how to obtain terminal access in the Android VM. The ISO we picked included a terminal emulator app bundled in, which is what we used. The reason we want to verify what tools are available is to see what we'll be able to use to move files over later or to help enable better monitoring of the machine. After installing everything you need to, the last step before turning off the VM is downloading the Malware APK, but do not install it yet. Arguably, the most important step is setting up the network. We wanted to use an isolated network because we don't want to let the malware reach out to the internet. Both the VMs will be put on this network in order to allow them to communicate. That way, our observer VM can act as a proxy to catch some of the requests that the malware might make. The main reason we chose to use this approach is because it also reduces the risk to us when we let the malware run. So now we configure the network adapters of the VMs to use the host-only network that we just created. We make note of the IP address that the Ubuntu VM was assigned since we'll be using that one to set up the proxies on the Android VM. For this demo, we will show us using burp, although we did try to set up several tools. As a quick note, something else we tried to do, albeit unsuccessfully, was set up fake DNS. We tried to manually configure the gateway and DNS server on the Android VM. However, this proved to be a bit tricky due to how the Wi-Fi adapter is emulated in the VM. We spent a few hours on this, but we were not able to get it to work. Assuming we were able to set up the observer VM as the DNS, however, we could have used fake DNS, which spoofs the DNS server, and iNetSim, which fakes some popular responses to make the malware think it's able to reach the internet. Sometimes this is helpful if the malware sends a probe out first before doing anything malicious. One final note is in the demo you'll see us running TCP dump to capture traffic. Initially we thought we would just write this to a PCAP file, turn off the VM, and grab it from the VDI file. However, it turns out Android started encrypting its file system several versions ago and this was not possible. We can't just email it over because we have malware on the VM and we do not want to give it access to the internet. What we ended up doing was using a gist snippet to set up a simple server on the Ubuntu VM which allowed file uploads. Using that, we sent the file over from the Android VM to the Ubuntu VM. Now for a live demo of our dynamic analysis. First, we're just going to check how the legitimate apps behave. So we're going to open up WhatsApp. It's going to ask us for a number, which we don't have, so we're just going to exit out. Now we're going to check out the banking app. This is the first time we're starting it up, so it's just going to walk us through the initial setup. We're going to click here, and now we're going to see the little permission screen telling us what permissions it's going to ask for and why. So we're going to allow these. Here's a little prompt from WhatsApp because its probes failed. Now we're going to click here to try and log in via card number, but we don't have a card, so we're going to click the login via username option. So we're going to try a fake username to see what happens. Let's try and log in, and we're going to get a little error actually from the app because it's detecting that, well, it thinks that we're either not on a 3G network or lower, or it believes that we are on a 3G network or lower, and therefore we don't meet the security requirements that the app requires of us in order to be able to use it. Okay, so now let's focus on the fun part of this, which is installing the malware APK. So this is the malware APK that we downloaded before we switched to the host-only network. We're going to double click it. Okay, so now we have to allow installing apps from unknown sources. As you can see, it's the Android VM itself isn't super receptive. There's still like some troubles that we have to deal with due to like it not recognizing some inputs that we give it. Alright, so now we see some of the permissions that this app is going to require. One of the more interesting ones is the one at the top, where it says this app can appear on top of other apps. This is actually how the overlay functionality of the app works when it'll try to detect that that legitimate WhatsApp is running, and it'll try to overlay on top of it so that we could put in our credentials thinking we're accessing WhatsApp, when in reality we're accessing an overlay that this app threw up to try and steal our credentials. Okay, so we've successfully installed the malicious malware. Now we've installed it, but we haven't started it up yet. So before we start it up, we want to just start a packet capture. The reason we want to start a packet capture is because although we're using Burp, we're using the community edition, so if we want to analyze what happened here later, we won't actually be able to save that with Burp. The packet capture will also capture more stuff that is going on the network, so we're just going to start that up before we actually start messing with anything else to make sure we capture as much information as possible that we could analyze later. So let's check really quickly if it tries to overlay on the newer version of WhatsApp. Doesn't look like it did. We're going to click agree and continue to see if maybe it depends on what screen it's on. No, doesn't look like it did either. Now let's check the banking app. Doesn't look like it's able to overlay on this one either. So keep in mind that zscaler actually walked through how it was able to overlap on the older versions of those apps, but since they already did that, we wanted to focus on to see how it would behave with newer versions of these apps. So here we actually get a prompt that this app is trying to request becoming a device admin app. And if we look on the left, we'll see some requests that Burp Suite was able to catch, and it's already trying to reach out to the C2 server, C2 standing for command and control. So before we've even started logging in or anything, we just booted that for the first time, we already see it trying to reach out. Alright, so we're going to allow it to be a device admin app, and now we see the old original login screen for the banking app, which it had 5 years ago. And so let's try to log in. So we're going to click here to log in. Now it's going to ask us for a username and password. So let's put in some fake credentials. For username, we're going to use testing, and we're just going to make the password password. So now we get a little error message saying like it had difficulty logging us in. This is just the Burp Suite page saying like, hey, you tried to reach this domain. We don't know what it is. That's because we're on a host-only network and it can't reach outside. But if we look on the left, we can see the request sent from this app to the C2 server that contains the credentials that we just put in, which was testing and password. So now that we booted up the app, let's see if that would now allow it to try and overlay. Looks like it's still not able to overlay onto the newer version of WhatsApp. So now we're going to check the banking app. Looks like it's still not able to overlay on the banking app either. Let's try to see if it's trying to look for a specific window. Nope, it wasn't really able to overlay on the newer version of the banking app either. So as we noticed before, this app became a device admin app. It actually does something pretty interesting for persistence, which we're gonna showcase now. So let's just find the device admin app settings. Awesome. Okay, it's taking its sweet time. All right, so now we're at the settings page. Let's click on device admin apps. We see the malware banking app right there. So now let's try and disable it. Okay, it's gonna ask us, are we sure we want to deactivate this device admin app? We're gonna try to click yes and okay. We get the prompt, but we can't actually click on anything anymore, and we actually got kicked back out of the menu. So now let's see if it was actually able to get removed. Let's go back to the device admin apps menu. Okay, it's still a device admin app, so let's try to disable it again. We get back to this menu asking us to confirm. Let's click this. And we see that it's trying to lock the screen of the device, which it was now able to do. And so it's doing all this to prevent us from being able to downgrade its level of access, and this is how the malware is able to stay persistent.
Here are some preventions you can follow to avoid getting malware. Only install apps from trusted sources. Google Play Store and Samsung Play Store seems to have good security policies and do a decent job keeping malware off their stores. Huawei's App Gallery has recently been found to contain malwares. Amazon App Store opens the device up to attacks due to requiring lowering security for installation of the store itself. This can leave the user vulnerable to malware installations. Apploid claims to have good security pipeline describing 3 forms of quality control to prevent malicious apps from entering the store hub. Fdroid is a fork of Aptoid and also follows their security foundations. In general, what can be done is to verify the developers of an app and check for certifications. For example, PlayProtect for Google Play Store. If you happen to get an unknown APK, it's also a good idea to scan it before installing. You can also verify hashes of downloaded APKs if the developer provides them. Also, we all know double check what permissions apps are asking for. In general, rooting the device is never recommended since you lose out on security updates. You might also want to be aware of drawing over other apps. This is a permission that is allowed or can be disallowed at a system level or individually for each app. Which app will be required legitimately? Well, YouTube actually draws over other apps. If you switch over to another app while a video is playing, the player minimizes but stays in the foreground while you use the other app. And finally, you can install an antivirus to handle some of these checks for you. So let's say we failed prevention and got infected with malware. What can we do then? Installing an antivirus may be tricky. Ideally, you would have it installed before you get infected, but let's say you didn't and you ended up with a malware on your device. You can try and install an antivirus to help remove the malware. However, some malwares may try to interfere in this process. Another option is to go into safe mode and remove admin rights for malicious apps and uninstall them. And finally, a last resort is to do a factory reset.
Let's close things out with some final thoughts. What did we learn? Well, we went through the process of analyzing malware. This was something we really enjoyed learning, and we were able to use the zscaler blog as a reference to make sure we were on track. The lab setup took a long trial and error process, but with what we learned here, we can apply towards a new APK. This feels like a great takeaway since we can reuse what we learned here to keep analyzing some more Android malware.